So as far as I can tell, this is the hardest question that's on Webwork 11. This is for Math 100 or 180, and it's problem 13. Um, so the first thing I want to say about this is there's probably like 5 or 6 different little tricks you need to know to be able to solve this problem. That's kind of what makes it so hard, is that it's really a compound problem. Now, the goal of this question, if you feel overwhelmed, don't worry about it. The goal should be to learn as many of these little tricks as possible. Okay, so if you can only get 2 or 3 of them, but you really understand those 2 or 3, then that's awesome. Don't feel bad about not getting all of them, because like I said, it is the hardest question. So let's get into it. So yeah, so you're going to have a number, you're going to have this constant in front of your function. Let's forget about that for now. That's going to be really, really easy to take care of after. If we can find the limit of f at x as pi goes to, here's our limit, right? As x goes to pi over 4 of just this stuff here, then we'll put the 7 in later. So anyway, like I said, we're going to start with just f at x equals this stuff here. And then the first thing to do, I think there's a couple ways to do this problem, but this is the way I do the problem. The first thing to do is to, well, I guess we notice that it's a L'Hopital's rule question, but we don't have indeterminate form. That's probably the first thing to notice. Right, to use L'Hopital's rule, we have to have 0 over 0 or infinity over infinity, which we don't have. We have an exponent to an exponent. As x goes to pi over 4, tan goes to what? You should know that. That's unit circle stuff. If you don't, that's one of the tricks. That's one of the little compound things. You got to look up your unit circle. So as x goes to pi over 4, tangent of x is going to go to 1. Now, tangent of 2x as x goes to pi over 4, 2 pi over 4 is a pi over 2. Tangent pi over 2, we got problems there, right? That's your asymptote. So that's going off to infinity in one direction, negative in the other direction. So it's pretty hard to say if you've got tan x going to 1 and then this going to infinity, I don't really know what's going to happen. You know, you can't just intuitively say, oh, it's going to be 5 or something like that. Some of these questions you can just look at it and be like, oh yeah, it's going to go off to infinity for sure. Here's why. Anyway, you can't do that here. So what do? We log both sides. Why? Well, that'll become more clear in a moment. So we get log of f at x is equal to, why is this down here? You should know that if you take the log of an exponent, that the exponent is going to come down. All right, now, why do we do that? What's going to happen now? So we get tangent of 2x, and as I said, as x goes to pi over 4, tangent of 2x is going to go off to infinity, and then log of tangent of x goes to 1 as x goes to pi over 4. Log of 1 goes to 0, and I write that stuff down here. Now that we have something like infinity times 0, we can, this is good enough for L'Hopital's rule. We know, so this should trigger in your brain when you get 0 times infinity, you don't really know which one wins, but that's okay because we can always, from this step, we can always manipulate it to use L'Hopital's rule. How? Well, you take one of these things, in this case, I'm going to take this tan of 2x, and I'm going to replace it with 1 over tan of 2x. So that this statement here becomes this statement here. I haven't taken any derivatives, I've just manipulated it. So this top part's going to infinity, and then this bottom part, this top part's going to 0, and this bottom part is now going to 0 also. So I've made it into indeterminate form. And like I said, that's another one of those tricks, and you can always do that if you end up with something like 0 times infinity. You can do that manipulation trick to get it into the proper form. Now we can use L'Hopital's rule. We can take the derivative of the top and the derivative of the bottom separately. Don't use quotient rule. Actually take the derivatives separately, and the limit of that original quotient is going to be equal to the limit of the derivatives, the individual derivatives of those quotients. That's what L'Hopital's rule says, and so that's what we can do. So yeah, so I write what's going to happen there. This is derivative stuff. This is a chain rule here, so it turns out to be this thing here, and then the derivative at the bottom, that's an ugly quotient rule. You can do that, you know, a number of ways. You can make that tan of 2x to the -1, and then make that a chain rule, or you can use quotient rule on this. I chose to use quotient rule. I like using quotient rule because I like getting quicker with it, because sometimes it's really important to just be sharp with your quotient rule. Anyway, so you get that, and then I hope I'm not going too fast, but I'm trying to get everything done in as little time as possible. So now once you get to this part here, you just need to know your unit circle essentially. Okay, that's super, super important. If you don't know your unit circle, spend some time, look up some YouTube videos on that, on how to memorize the unit circle and what it means. How does it relate to the graphs of sine and cosine? That's important, and tangent, therefore. And also, you get the secondary trig functions, so you're going to get cosecant, cotangent, and secant as well. If you know the original ones, you, of course, get those ones as well. So the unit circle really ties all that stuff together. Okay, so yeah, if you know these three things, notice those are the only trig functions in our limit that we have yet to compute. So it's just now a matter of knowing the unit circle, plugging things in, and getting a value there. So is that our answer? No, that's not our answer because we didn't take the limit. If you remember, we did this little trick up here. We didn't take the limit of f at x as x goes to pi over 4. We took the limit of log of f at x as x goes to pi over 4. So now we have to, how are we going to use log of f at x? Well, we can use this trick here. So limit as x goes to pi over 4 of f at x is equal to limit as x goes to pi over 4 of e to the log f at x. Okay, because remember, e and log are inverses. This is the natural log here. E and log are inverses, so this is really the same thing. But this log of f at x part we can use because we know the limit as x goes to pi over 4 of this log part. Anyway, I won't just give away the rest of the answer. I might get in trouble. I don't know. So I'm not going to give it away. But that's essentially the whole work. And don't forget to take into account your constant. Everyone has a different constant here. And yeah, that should lead you to victory. So remember, you know, it's a hard question. Don't feel down if you don't get the whole thing. Just try and understand as many of the parts of that explanation as you can. The more you know, the better you'll be. And thanks for watching.